Hey everyone! In this video, we are going to be converting a velocity time graph to a position time graph, but we have a sloped velocity. So we've worked with velocity time graphs where it's been flat the whole time, but with a slope, the trick is to actually make it flat. And to do that, we're going to take the average of what the velocity is. So in this case, that little sloped velocity, it went from 0 to 4. So we can actually just treat it like it's 2 the whole time. And that way we don't have to deal with the slope at all. And this is a bit of an approximation, but that gives us the slope of our position time graph. So over 1, up 2, over 1, up 2, over 1, up 2. And we can connect those. And this will give us a line for our position time graph, which is a pretty decent estimate of what it's going to look like. So we traveled a total of 8 meters in 4 seconds, which is true. Whether you have that little sloped line or not, it's going to be 8 meters in 2 seconds. But there's more. You see, if we want to get a better estimate, what we can start doing is cutting up each little region of that velocity time graph. So in that first second, we can get a little mini average of a half, because that was the average in the first second, which means we go over 1, up a half. In the second, looking only at the velocity in that time, the average in that interval was 1.5, which means for the second, we're going to go over 1, up 1.5. Now, stick with me here because you're going to see where this ends. In that third little interval, our average velocity is 2.5. And again, I'm just looking at that little interval in between 2 and 3 seconds. The velocity in that time, just draw a straight line across, average it out. It's 2.5, which means our slope is over 1, up 2.5. And in our last one, our final little average velocity between 3 and 4 seconds is 3.5. Yeah, it's just between that 3 and the 4. And we can head over and we go over 1, up 3.5. We're in the exact same spot, working as intended. But if you go up by the little intervals, we're actually going to get a much cooler curve. And oh, I messed that up, my little drawing there, but I can fix this. I can fix this or make it worse. It's okay. Okay, I like it. I like it. It looks like a parabola. And you see, if the velocity on a velocity time graph is a linear function, that position time graph, if you do that velocity in little chunks, will turn out to look like a little parabola. Now our first line there, that green line, that's a good estimate. It's a decent estimate. And if you're just getting started with this, that hack will help you switch these. But if you're getting a little further into converting velocity time to position time, going in little chunks will help you. We're going to do another example here. So this is example number 2. We have another velocity time graph. It has another sloped velocity. It goes from 3 to 0, which means the average velocity over this interval is 1.5. We can get a good little approximation here. If the velocity average is 1.5, we just go over 1, up 1.5, over 1, up 1.5, over 1, up 1.5. And we can connect those dots. Hey, that line is a beautiful little approximation of our position time graph given that velocity time graph. But if we go little stepwise second by second interval, we can do even better. In that first second, we can figure out, so it goes from 3 to 2 meters per second, which is an average of, oh no, the blue don't work at all, let's go back to yellow, 2.5 meters per second. 2.5 meters per second. That's the average in that first second, which means on our position time graph, we go over 1, up 2.5. That's in a slightly different spot than our first line. It's a little bit higher. In the next interval between 2 and 3 seconds, or sorry, between 1 and 2 seconds, it is an average of 1.5, which means our slope of our position time graph should be over 1, up 1.5. Again, a little bit higher than our line. In the final interval between 2 and 3 seconds, it's an average of a half. It went from 1 second to 0 second, which means our final slope is over 1, up a half. Again, it gets us exactly where our approximation landed, except if we connect these new dots based on each little interval, Ooh, oh, okay, I nailed it that time. I nailed it that time. That's a quadratic. That's a quadratic. That little curve there, that is an even better approximation. And don't get me wrong, that yellow line in the position time graph, if you're just getting started, whew, that is fast and you can use it. But if you're trying to get fancy, get the averages second by second or even smaller intervals, and it will give you that much, much nicer curve. We're going to go ahead, do one last example. This one got brought to me by one of my students, and they are such clever little cupcakes. They figured this out, knew it was a problem. What happens if the average is 0? In this case, we have a velocity time graph. It goes from +2 to -2, which means the velocity over this interval is 0 meters per second, which means over these 4 seconds we don't go up, which means it's a straight line. And this is an example of when the approximation will fail you. Yeah, I know, sad face, sad face. It didn't work. We have to do the little piecewise interval steps here. So let's go ahead and see what this looks like if we do it second by second. From 0 to 1 seconds, we have an average of 1.5, which means our slope is over 1 up 1.5. Between 1 and 2 seconds, that average, so where that red line, that velocity line goes, the average is 1/2, which means over 1 up 1/2. Okay, going well so far. Let's get the next little interval. In the next interval between 2 and 3 seconds, if we work out that average, this time that average works out to be a flat line at -1/2. -1/2, which means we go over 1, down 1/2. Okay, see, we could still do this. And in the final interval, that average works out to be -1.5. Okay, we just average it out between that 3rd and 4th second. No problem. It went from -1 to -2, so it's a -1.5. That went over 1, down 1.5. And when we connect these, instead of having that flat line straight across, oh, look at this shape. Look at this shape. Oh, I messed it up in the end, but it was still pretty good. We get a parabola. We get a parabola, and this is when doing the little second by second averages, instead of just a big average of that sloped line, is really going to help you get that nice curve in the position time graph. I hope that this was helpful for you. Eventually, my students always ask, what if we did even better approximations? What if we did like averages every half a second or a quarter of a second? And to that I say, ha ha ha, calculus is coming. Good luck. I hope you enjoyed this. If you have any questions, please leave them in the comments down below. Thank you very much for watching, and I'll be looking forward to seeing you next time.